Look up tonight. Have you ever noticed how some stars glow like warm embers, while others blaze with icy fire? What mysterious forces paint the night sky in these striking reds and blues? Just beyond the quiet hush of your room, past the city lights or the whispering trees, the night sky spreads wide and deep, a vast ocean of darkness, studded with shimmering stars. Some stars glow with a warm, gentle red light, like the ember of a fading fire, soft and comforting. Others blaze fiercely, burning blue-white, sharp and brilliant as the cold flame of an otherworldly torch. Have you ever wondered why the stars were such different colors? Why does the night sky sparkle in a rich palette of reds, oranges, yellows, whites, and blues? What stories do these colors tell? Not just about light, but about time, heat, and the very life of the cosmos. Tonight, we'll take a slow, gentle journey to uncover the secret behind star colors. Together, we'll explore how stars sing their own light song, a language of temperature and energy, size and age, chemistry and motion. We'll see how their colors reveal their inner fires and their place in the great cosmic dance. Before we begin, welcome to the thoughtful night, your quiet corner of the universe where wonder meets calm. If you love drifting to sleep with awe and curiosity in your heart, please subscribe and tap the little bell. It helps you find your way back to peaceful stories of science, softly told. And I'd love to know, from where are you watching tonight? Maybe a cozy city apartment, a quiet countryside, or somewhere far away beneath a blanket of stars. Leave a comment below and share your night sky. Now, take a slow, deep breath. Feel your body relax. Let the worries of the day melt like morning mist under the sun. Together, we'll let the stars whisper their secrets as you gently drift towards sleep. Are you ready? Let's begin. Step outside tonight. Find a quiet place where the stars stretch out above you, vast and endless. Take a moment to simply look, without thinking. Let your eyes roam across the night. What do you see? A sparkling tapestry of lights, each one a small glowing point suspended in the deep black canvas of the cosmos. Some stars glow with a soft reddish hue, like the gentle warmth of a dying ember. Others shine bright, almost icy blue, like distant flames burning with a fierce cold. Between these extremes are stars tinted with golden yellows and creamy whites, each casting their own unique glow. This natural palette, red, orange, yellow, white, blue, has painted the night sky for as long as humans have looked up. And yet, for all its beauty, it is a mystery that has puzzled minds for millennia. Ancient people noticed the difference in star colors long before telescopes or modern science. They gave names and stories to these lights, weaving myths about fiery gods, celestial battles, and messages from the heavens. To them, the colors were symbols, omens of fortune, of fate, or the gods' moods. But as our understanding of the universe grew, so too did our curiosity deepen. What truly causes a star to glow red or blue? What cosmic secret lies behind these colors? Stars, as it turns out, are much more than pinpricks of light. Each star is a glowing sphere of gas, a furnace of nuclear energy burning steadily for millions or even billions of years. Their colors are a window into their inner nature, a language written in light and heat. The reds you see come from stars cooler than our sun. Their surface temperature's like a gentle hearth fire, steady and calm. The blue stars, in contrast, burn at blistering temperatures, tens of thousands of degrees hotter, their light intense and fierce. Between these extremes lie the yellows and whites of stars like our sun, shining with moderate heat and steady brightness. This cosmic color wheel is nature's way of showing us the life and energy of the stars, their youth or old age, their size, their secret chemistry. And tonight, as you listen softly, we will unravel this cosmic language together, gently peeling back the layers of mystery so you can see stars not just as distant lights, but as living stories written across space and time. Look now at a bright red star, perhaps the famous Betelgeuse in the constellation Orion. Its deep red glow is a sign of a cool surface compared to others, but it's no small star. Betelgeuse is a giant, many hundreds of times wider than our sun, glowing in the last chapters of its life. Nearby, the blue star Rigel blazes, hotter and younger, its light sharp and powerful. Here, in this color contrast, lies a beautiful truth. Temperature shapes color, and color tells a story of life. Each star, with its unique hue, whispers a cosmic secret, waiting for us to listen. As your eyes slowly wander across the sky, remember, this rainbow of star colors is nature's ancient code, inviting us to dream, to wonder, and to understand. And so our journey begins, through light, heat, and time, to discover why some stars are red and others blue. Close your eyes for a moment. Imagine light, not just the light you see, but the very essence of it. Light is more than brightness. It is a messenger, a story, a language spoken across the vast emptiness of space. When a star shines, it sends out billions of tiny packets of energy called photons. These photons journey across unimaginable distances, sometimes millions or billions of years, before they reach your eyes. Each one carries a secret, a piece of the star's story. The colors we see in the stars are not random. They are written in the wavelengths of this light, the very waves along which energy travels. Think of these wavelengths like different musical notes. Some waves are long and slow, like a deep, soothing bass. Others are short and quick, like a high-pitched trill. The length of the wave decides the color your eyes perceive. Long waves appear red, while short waves show as blue. Somewhere in between are oranges, yellows, and whites. This spectrum of colors is nature's secret language. Imagine a prism, a simple glass triangle. When sunlight passes through it, the light splits into a rainbow. This happens because white light is actually made of many colors, each bending at a slightly different angle. Stars work in a similar way, but instead of a prism, their colors come from the star's own physical conditions, temperature, size, and composition, shaping the light they emit. The warmer a star, the shorter the wavelength of its light, and the bluer it appears. The cooler the star, the longer the wavelength, and the redder it glows. So when you look up at a blue star, you are seeing light packed with more energy, traveling in quick, short waves. When you see a red star, the waves are longer and calmer, carrying less energy but no less beauty. Light is the language stars use to tell us who they are. But light is more than just waves. It is also a measure of time. Because light takes time to travel, the stars we see are ancient. We are looking back in time. The red star you see might have already changed or even disappeared, but its light keeps arriving, a cosmic echo from the past. In this way, starlight is a whisper from history, a lullaby sung across space and time. Imagine how quiet the universe must be, with stars softly sending their light across the dark. Each photon, a gentle traveler, crossing the abyss, to rest briefly in your eyes before vanishing forever. This thought alone can calm the restless mind. When we learn to read this language of light, we learn to see stars not just as points of brightness, but as living stories, each color a stanza in the endless poem of the cosmos. Tonight, as you lie still, imagine yourself as a traveler, receiving the light star's message, bathed in a spectrum of warmth and cold, fire and ice. Let this language lull you deeper, as the universe sings its quiet song of color and light. Imagine holding a thermometer in your hand, a simple tool that tells you whether the air is warm or cold, a whisper of the weather around you. Now, imagine a cosmic thermometer, one that measures the fiery heartbeats of stars scattered across the universe. Stars, in their silent brilliance, reveal their temperature not by touch, but by color. This is their cosmic thermometer, a natural gauge, painted in hues from cool red to scorching blue. Red stars, glowing softly with deep warmth, might seem gentle, but their temperature is still far hotter than any flame on Earth. These stars hover at surface temperatures around 3,000 degrees Celsius, a fiery hearth compared to our everyday fires, yet the coolest among stars. On the other side, blue stars burn fiercely, with surface temperatures soaring above 20,000 degrees Celsius, and some even reaching over 40,000 degrees. Their blue-white light tells us of an intense, searing heat far beyond human experience. And in between, stars like our sun shine yellow-white, their surface simmering at about 5,500 degrees Celsius, a moderate fire, steady and life-giving. Why does temperature paint such a vivid color story? The secret lies deep inside each star, in the balance of forces and energy flowing within. Stars are massive spheres of gas, mostly hydrogen and helium, held together by gravity's quiet pull. At their core, hydrogen atoms fuse together, releasing vast amounts of energy in a process called nuclear fusion. This energy fights to escape outward, pushing against gravity's pull inward. The surface temperature we see is where this energetic struggle finds a kind of peace, a calm boundary between stars' blazing core and the coldness of space. Hotter stars have more intense fusion happening in their cores. This means more energy rushes to the surface, heating the outer layers to incredible temperatures, making the star glow blue or white hot. Cooler stars burn their fuel more slowly, their surfaces glowing red or orange, as if the fire inside is smoldering rather than raging. But there is more. Temperature also relates to a star's size and lifespan. Blue stars, the hottest and brightest, are often giants or supergiants, massive stars burning fuel at a furious rate. Because they consume their energy so quickly, their lives are brief, sometimes only a few million years. Red stars can be giants too, old stars nearing the end of their lives, or they can be smaller red dwarfs, quietly burning for tens of billions of years, far longer than our sun. The color and temperature are not just about heat, but tell a story of a star's age, size, and fate. Your own sun, a yellow dwarf star, sits comfortably in the middle of this cosmic thermometer, a life-giving furnace that has burned steadily for nearly 5 billion years and will continue for billions more. In this way, the colors you see when you gaze up are like nature's way of measuring cosmic time, from the brief and brilliant youth of blue stars to the slow, steady burn of red dwarfs, to the aged glow of giant red stars nearing their end. These temperature hues also influence the worlds around the stars. The kind of light a star shines affects the planets that orbit it, shaping climates and possibilities for life. A blue star's fierce radiation may scorch nearby planets, while the gentle warmth of a red dwarf might allow worlds to simmer in slow, steady heat. As you imagine this cosmic thermometer, feel the warmth of these distant fires blending softly with the cool night air around you. The star's colors are not just science. They are a cosmic lullaby, soothing and deep, painting the night with the rhythms of light and heat. They remind us of the vast scales of time and temperature that stretch far beyond our daily lives, inviting us to rest within the embrace of the universe's steady pulse. As your breath slows and your thoughts drift, imagine yourself wrapped in this gentle glow, the red warmth, the yellow calm, the blue blaze, all woven into the peaceful night sky. The stars' colors become a quiet song, humming softly as you fall deeper into rest. Tomorrow, when you look up again, remember the cosmic thermometer and the story it tells, in reds and blues, in warmth and cold, in youth and age. Each star is a beacon of fire, measured and marked by its own glowing temperature, a vast, silent symphony of light. And so, with this warmth in your heart and the stars above, let your mind drift, calm and curious, towards sleep. Imagine a star as a living being, with a life story that unfolds across millions or even billions of years. Like all living things, stars are born, they grow, age, and eventually die. Their size and age shape not only their color, but the very nature of their existence. The smallest stars, known as red dwarfs, are the quietest and most enduring. These tiny, cool stars burn their fuel so slowly that they can shine steadily for tens of billions of years, far longer than the current age of our universe. Though faint and small, their persistence makes them cosmic elders, patient lights glowing quietly in the darkness. At the other end of the scale lie the massive blue giants, bright, hot, and breathtaking in their intensity. These giants live fast and burn bright. Their enormous size and furious fusion at their cores mean they exhaust their fuel in a mere few million years, a blink in cosmic time. Then, they die spectacularly, often exploding as supernovae, scattering elements that seed new stars, planets, and eventually, life. Our sun is a middle-sized, middle-aged star, a yellow dwarf. It's about 4.6 billion years old, shining steadily and providing the perfect balance of warmth and stability that makes life possible here on Earth. The sun's life story is calm compared to its massive cousins, but no less remarkable. The size of a star affects its brightness and color, but it also governs its destiny. Large stars, with more mass, have stronger gravity compressing their cores. This higher pressure fuels rapid fusion, creating more energy and higher surface temperatures. That's why many massive stars glow blue or white hot. Smaller stars, with less mass, have gentler core pressure, slower fusion, and cooler surfaces. They glow red or orange, modest fires that last long and steady. But age is the artist that reshapes stars over time. Young stars often shine white or blue, signs of fresh energy and fierce fusion. As they age, they swell and cool, sometimes expanding into giants or supergiants. Their color shifts toward red or orange as their surfaces cool, even while their cores burn hotter. Betelgeuse, the red supergiant you see in Orion, is a great example. Once a bright blue star in its youth, it has grown enormous and cooled at the surface, glowing a deep, comforting red as it approaches the final stage of its life. These changes mark a star's slow transformation, a cosmic aging process that lasts millions to billions of years, a dance between gravity and nuclear fire. Stars live in cycles, from birth in vast clouds of gas and dust, known as nebulae, to their eventual death. When a star dies, it can leave behind beautiful remnants, glowing nebulae, dense white dwarfs, neutron stars, or even black holes. These remnants enrich the cosmos with elements forged in the star's heart: carbon, oxygen, iron, building blocks for planets, and for life itself. So, when you look at the night sky, you're witnessing a gallery of star stories, each telling its own tale of size, age, and change. Some stars are ancient elders, quietly glowing red, while others are fiery youths blazing blue. All are part of the cosmic cycle: birth, life, death, and renewal, an endless rhythm playing out across time and space. As you rest beneath this living sky, imagine yourself wrapped in the soft glow of these stories, connected to the vast, unfolding life of the universe. The stars remind us that change is natural, that endings bring beginnings, and that even the smallest light has a place in the great cosmic dance. Let this thought settle gently in your mind as you breathe deeply and feel yourself drifting toward peaceful sleep. Look up once again, deep into the night, and consider the twinkling stars. They are not just balls of gas glowing with heat and light. They are cosmic laboratories, forges where the elements that build everything around us are born and shaped. Every star carries a unique chemical signature, a recipe of elements forged in the heart of its fiery core. This chemistry, hidden within the light they send out, reveals secrets about their past, their present, and even the fate of the universe. How do we read these secrets? When starlight passes through a prism or a telescope spectroscope, it splits into a rainbow, a spectrum of colors. But within this spectrum, tiny dark lines appear, known as absorption lines. These lines are like a star's fingerprint, each corresponding to a specific chemical element absorbing certain wavelengths of light. By studying these lines, scientists can decode the chemical makeup of stars, discovering the presence of hydrogen, helium, carbon, oxygen, iron, and many more. Hydrogen, the simplest and most abundant element in the universe, makes up about 75% of a star's mass. It is the fuel for the nuclear fusion that powers stars, hydrogen atoms smashing together to form helium and releasing immense energy. Helium is the second most common element, born in the earliest moments of the universe and continuously produced inside stars. These two elements dominate the stellar composition, but heavier elements play vital roles too. Inside massive stars, temperatures and pressures reach such extremes that heavier elements fuse in successive layers, creating a complex onion-like structure of elements from carbon to iron. When these giants reach the end of their lives, the core collapse can trigger a supernova explosion, a brilliant, violent outburst scattering these heavy elements into space. This cosmic enrichment is the source of all elements heavier than hydrogen and helium in the universe. Elements like calcium in your bones, iron in your blood, and oxygen in your breath were once forged in the heart of a star and cast across the cosmos. Every atom inside you was born in starlight. In smaller stars, such as red dwarfs or our sun, fusion creates mainly helium, but they too contribute to the cosmic cycle by eventually shedding outer layers, enriching space with new material. Stars are both creators and recyclers, the chemistry within them shaping the building blocks of planets, oceans, and life. This stellar chemistry is not just a scientific fact, it is a poetic reminder of our deep connection to the universe. When you see a star shining red or blue, remember that its color is a messenger not just of temperature and age, but of the complex elements it carries, a treasure trove of cosmic history. The light that reaches your eyes carries whispers of hydrogen's ancient fusion, of carbon's creation, and of iron's final, brilliant moments. Each star glimmers with the story of matter, a story that stretches from the birth of the cosmos to the life growing quietly within you. As you let your thoughts soften and your breath slow, imagine the stars as endless alchemists, turning simple elements into the rich chemistry of the universe. Feel the warmth of this connection as the night wraps around you, a gentle reminder that we are all made of stardust, glowing softly in the vastness. Let this thought carry you deeper into rest, embraced by the quiet brilliance of the elements born in light. The stars we see are not only blazing spheres of light, they are delicate painters, blending hues shaped by the atoms within them. The colors that reach our eyes are not random. They are the result of the unique chemistry swirling inside each star. Imagine a cosmic dance, atoms spinning, colliding, and releasing light, their tiny fingerprints etched into the glow we witness. Hydrogen and helium, the universe's most abundant elements, play leading roles in this luminous ballet. Hydrogen, with its single electron, emits light in distinct patterns, bright lines within the star's spectrum that add to its characteristic color. Helium, slightly heavier, dances with a different rhythm, contributing its own spectral notes. But it's not just these light elements shaping the star's palette. Heavier elements, forged in the star's core or inherited from previous generations of stars, add subtle shades and tones. Elements like iron, calcium, and carbon absorb and emit light at very specific wavelengths, painting intricate patterns into the star spectrum. This chemistry influences the star's temperature, brightness, and ultimately its color, whether a warm red glow or a fierce blue flame. For example, Stars rich in certain elements may have atmospheres that absorb more blue or red light, subtly changing the color we see. The interplay of atoms and light is a delicate, poetic dance, one that tells the story of the star's inner life. Every flicker, every shade in a star's light is a message, a signature of the elements within and the processes at work. As you listen, picture this atomic choreography, where electrons leap between energy levels, releasing photons of specific colors. Imagine the star's atmosphere as a grand stage, where each element plays its part in the symphony of light. This chemistry of color is the language stars use to tell their stories across time and space, reaching us through the vast silence. Let yourself feel the wonder of this unseen, intricate dance as your mind slows and your body relaxes. With each breath, sink deeper into the quiet mystery of stars, nature's painters of the night. Look up once more, but now close your eyes. Imagine a world where the colors of stars are not just what your eyes can see, but a vast spectrum extending far beyond. Ultraviolet waves and infrared whispers, hidden colors that dance silently across the cosmos. Human vision is limited, tuned only to a narrow band of light called the visible spectrum. This tiny slice is just a small window into the grand, luminous orchestra that stars play. Beyond violet lie ultraviolet rays, energetic and fierce, invisible to us but powerful enough to shape the fate of nearby planets and ignite cosmic chemistry. Beyond red stretches the gentle glow of infrared, a warmth that we cannot see but can feel, like a quiet breath of heat flowing across space. This hidden light tells stories of star births cocooned in clouds of dust, secrets veiled behind glowing embers of newborn stars. Thanks to technology, we have found ways to hear these secret colors. Telescopes equipped with special sensors translate ultraviolet and infrared light into images and data we can understand. They let us peer into realms our eyes alone could never glimpse. Imagine the Hubble Space Telescope capturing ultraviolet light to reveal energetic young stars blazing in distant galaxies. Or the James Webb Space Telescope, sensing infrared light to unveil the cosmic nurseries where stars are born, hidden behind curtains of dust. These tools expand our senses, extending our perception beyond human limits, allowing us to experience the invisible hues that color the universe. They invite us to imagine what the night sky would look like if our eyes could see these hidden lights. If the heavens glowed not just in blue, white, or red, but with the ultraviolet fire of newborn stars and the warm, soft heat of star-forming clouds. This invisible spectrum is a realm of mystery and wonder, reminding us how much remains to be discovered. What colors dance around us now, unseen and silent? What secrets hide in the ultraviolet blaze or the infrared warmth that our eyes cannot reach? As you breathe deeply, feel the mystery of these unseen colors, the vastness of the universe not only in space and time, but in the hidden light that surrounds us. Allow yourself to expand your cosmic senses, imagining yourself drifting gently through this invisible spectrum. Let the quiet wonder of the unseen stars lull you deeper, cradled by the soft glow of a universe far richer than sight alone can reveal. Rest now, wrapped in the comforting hush of hidden light, dreaming of colors beyond the visible, vast, and infinite. In the vast theater of the night sky, some stars stand out with grandeur and grace, the ancient red giants and the brilliant blue supergiants. Their colors tell stories not just of temperature or chemistry, but of age, size, and the fate they are destined to meet. Red giants, glowing with a warm, amber light, are the elders of the stellar world. These stars began life much like our sun, but after billions of years, they have expanded to enormous sizes, their outer layers cooling and glowing red as their cores transform. Their bloated envelopes can swell to hundreds of times their original size. Imagine a star so large that, if placed at the center of our solar system, it would swallow Mercury, Venus, Earth, and possibly even Mars. The red color you see is a gentle signal of cooler temperatures near the surface, often between 3,000 and 4,000 degrees Celsius. Though cooler than blue stars, red giants shine brightly because of their vast surface area. Inside, their cores are hot and dense, burning helium into carbon and oxygen. This late stage of stellar evolution is a calm before the storm. Eventually, many red giants shed their outer layers, creating glowing planetary nebulae, leaving behind dense white dwarfs. On the other side of the spectrum blaze the blue supergiants, young, massive, and fiercely hot. These stars burn at temperatures upwards of 20,000 degrees Celsius or more. Their light, so intense it shifts into the blue and even ultraviolet range. Blue supergiants are rare but spectacular. They burn their fuel quickly, living short but brilliant lives, often only a few million years, compared to the billions that red giants may enjoy. Their immense mass means gravity fights fiercely with the outward pressure of nuclear fusion, creating dynamic, sometimes unstable outer layers that pulse and shine with dazzling intensity. Many blue supergiants are destined for dramatic ends, collapsing in spectacular supernova explosions that briefly outshine entire galaxies, scattering their enriched guts into space to seed new generations of stars and planets. These two types of stars, red giants and blue supergiants, represent opposite ends of a cosmic life cycle. Red giants are the wise elders, their fading warmth a lullaby to the quiet cosmic night. Blue supergiants are the fiery youth, blazing trails and leaving marks that shape the universe. Together, they tell the story of birth, growth, decay, and renewal, all wrapped in color. As you drift further into rest, imagine these stellar elders and firebrands dancing across the dark canvas above. Feel the weight of their stories, the heat of their light, and the endless cycles of life and death woven into their glow. Let the contrasts of red and blue, soft warmth and fierce flame, carry you deeper into the night's embrace. Breathe in the mystery, the vastness, the poetry of the stars. And know that within this cosmic dance, you are also a part, a child of ancient light, wrapped in the colors of the universe. Look up into the night sky once more, and imagine not just a single star, but pairs, twinkling companions bound by gravity, locked in an eternal celestial dance. These are binary stars, and their colors create some of the most beautiful contrasts in the heavens. Binary stars come in many varieties. Sometimes, two stars of similar size orbit each other closely, their colors blending softly like twin flames. Other times, the pairs are vastly different. A cool red giant glowing beside a brilliant blue supergiant, casting a striking palette across the sky. This cosmic pairing offers us a chance to witness color in conversation, where fire meets warmth, where young light brushes against aged glow. These stellar relationships tell us much more than just pretty colors. They are laboratories of cosmic physics, revealing secrets about star formation, evolution, and even the life cycles of stars. When stars form in the same cloud of gas and dust, they often come together as binaries or even larger groups. Their gravitational embrace influences how they grow and change, how they exchange matter, and how their colors evolve. In some binaries, matter flows from one star to the other, like a gentle river or a violent storm, changing their atmospheres, and, with it, their light. As these stars orbit and interact, their colors can shift subtly, sometimes creating dramatic eclipses or flickers in brightness. Imagine watching a blue star dim as its red companion passes in front, a delicate interplay of shadows and hues. This dance of light and color offers a reminder that stars are not solitary. They live in community, shaped by connections and cosmic forces beyond themselves. And as you rest beneath this spectacle, let yourself feel the harmony and tension of these stellar relationships. Picture the night sky as a grand ballroom, where stars swirl in pairs, each color telling a tale of friendship, rivalry, or mutual growth. The contrasts of red and blue, warm and cool, young and old, all intertwined in patterns woven by gravity's gentle hand. In their light, there is a quiet lesson. Even in the vast loneliness of space, connection creates beauty, complexity, and wonder. Breathe in the calm of this cosmic dance, and let your mind wander freely among the stars' stories. As your body sinks deeper into rest, carry with you the harmony of these paired lights, their colors painting dreams of unity and contrast. Let the night sky's twin flames soothe you, their eternal embrace a lullaby for your soul. The night sky is not a static painting, but a dynamic tapestry, alive with movement and change. Stars race through space, some speeding toward us, others drifting away, and this motion subtly shifts their colors in a cosmic symphony known as the Doppler effect. Imagine the sound of a passing ambulance. Its siren rises in pitch as it approaches, then falls as it moves away. Light behaves similarly, shifting its color depending on the star's motion relative to us. When a star moves closer, its light waves compress, shifting toward the blue end of the spectrum. This is called blue shift, a star's color seeming to brighten, growing cooler and more intense. When it moves away, its light stretches, shifting toward red, redshift, like the gentle fade of a distant ember, receding slowly from view. This color shift is not just a trick of perception, but a profound clue about the universe's dance. By measuring how much a star's light shifts, astronomers can gauge its speed, direction, and even the expansion of the cosmos itself. The Doppler effect invites us to think of stars not as fixed points, but as travelers, each with its own story of journey and change. They are restless wanderers, moving through the vast cosmic ocean, their colors shifting like whispers on the wind. Feel now the motion behind the stillness of the night. Each star you see is part of a grand ballet, swirling, moving, shifting hues as they race through the dark. This ceaseless motion connects us to the universe in a deeper way, reminding us that change is constant, and light itself carries the story of movement and time. As you breathe softly, let the thought of stars in motion lull you, their shifting colors painting a gentle rhythm that matches the slow pulse of your heart. Rest now in the knowledge that the universe is alive with movement, and you are part of this cosmic voyage. The Doppler effect whispers softly, a cosmic lullaby of light and motion, carrying you further into peaceful sleep beneath the ever-shifting sky. Look gently toward the sky in daylight, and there you see the star closest to you, our sun. It warms your skin and lights your world, glowing with a color that is neither deep red nor sharp blue, but a soft, comforting yellowish white. This familiar glow holds a special place in the story of star colors. While the universe bursts with reds and blues, our sun rests quietly in the middle, a star of moderate temperature and size. Its surface temperature hovers around 5,500 degrees Celsius, warm enough to shine brightly, but not so hot as to blaze with blue intensity. This middle ground places our sun in the spectral class known as G-type, sometimes called a yellow dwarf, although its light is actually more white than yellow when viewed from space. From Earth, the atmosphere scatters shorter blue wavelengths, painting the sky blue and tinting the sun's light with a soft golden hue, especially at sunrise and sunset. This warm light has nurtured life on our planet for billions of years. Its steady glow the heartbeat of day and night, growth and rest. Our sun is a star of balance, old enough to have settled into a long, steady phase called the main sequence, burning hydrogen steadily in its core. It's neither a young, hot blue star blazing through its brief life, nor a swollen red giant nearing the end of its days. Instead, the sun is a quiet guardian of life's rhythms, its color a gentle reminder of stability amid cosmic change. Yet, even the sun's color tells us about its chemistry and age, about the fusion reactions deep inside, and about the light and warmth it generously shares. In this soft glow, there is intimacy, a bridge between the vast universe and the personal world you inhabit. When you look at the sun's color, you're not just seeing light. You're witnessing a story of cosmic balance and life's delicate dependence on this steady star. Let your thoughts drift to the warmth you feel on your skin, the golden light bathing your surroundings. Allow the sun's color to become a comforting presence, a steady flame in your mind's eye as you settle into rest. Remember that while the universe is filled with stars of many colors, the sun's gentle light is the one that touches you most intimately. As you close your eyes, carry the soft radiance of the sun with you, a reminder of life, light, and the cosmic connections that link us all. As we near the end of our journey through the colors of stars, let us pause to reflect on what these glowing hues reveal about the universe itself. Each star's color is a quiet messenger, whispering secrets of age, temperature, and chemical makeup, clues that help us understand the vast cosmos we call home. When you look up and see a red star, you are seeing an elder, a star in its golden years, cooling and expanding, nearing the final chapters of its life. Blue stars, in contrast, burn with the fierce brilliance of youth, hot, massive, and fleeting, like brilliant fireworks against the night. In their light, we read stories of beginnings and endings, of cosmic cycles that stretch across billions of years. The colors also tell us about the very elements that compose the stars: hydrogen, helium, and heavier atoms forged in stellar hearts and supernovae, scattered across space to become the building blocks of planets, life, and even you. This is a universe that speaks in color, where light itself is a language, rich with meaning and wonder. Beyond the visible hues, technology has expanded our senses, letting us hear the silent songs of ultraviolet and infrared, revealing a cosmos far more vibrant than our eyes alone can perceive. Through this, we gain a deeper connection to the universe's rhythms, a sense of belonging to something immense and timeless. Understanding star colors also helps us chart the universe's past and future, measuring distances, ages, and the ever-expanding cosmic dance. And in this knowledge, there is beauty, a reminder that the night sky is not just a backdrop, but a living storybook, inviting us to read and dream. Let the colors of stars inspire awe and calm, a gentle invitation to keep looking up with wonder. As you drift toward sleep, feel yourself connected to this vast cosmic tapestry, where every star's light is a thread weaving you into the fabric of the universe. Carry this calm sense of belonging and curiosity into your dreams, where stars continue their silent, colorful dance. The night deepens around you now, a velvet blanket sprinkled with the gentle glow of countless stars. You have traveled through the universe of light, from the warm reds of ancient giants to the fierce blues of newborn stars. You've seen the colors that tell stories of fire, motion, and time, a celestial symphony played out in the silent darkness. As you lie here, ready to slip into dreams, allow the calm of this cosmic journey to settle softly within you. The stars' colors are not just distant phenomena, but gentle whispers from the universe itself, a reminder of the beauty woven into the fabric of existence. Each hue you've witnessed tonight speaks of connection between atoms and light, between youthful flames and ancient embers, between you and the vast cosmos. Remember that the light reaching your eyes has traveled across unimaginable distances, carrying with it stories from the heart of stars, from the beginnings of time to this very moment. Let this knowledge fill you with a quiet awe, a peaceful wonder that anchors you in the night. As your breath slows and your body sinks deeper into rest, imagine yourself wrapped in the glow of the stars, safe and serene beneath the endless sky. If this cosmic meditation touched your heart, I invite you to join our growing community of night travelers. Please subscribe to The Thoughtful Night, where we journey together through science, beauty, and wonder, one soothing story at a time. Leave a comment below telling me your favorite star color. Is it the gentle red of a giant, the bright blue of a young star, or maybe the soft white of our sun? Share where you're watching from, so we can connect across the miles and light years. And if you enjoyed this quiet voyage, please like and share it with someone who might find comfort and curiosity in the stars. Now, Let your mind drift with the stars' gentle rhythm, their soft light guiding you toward peaceful dreams. May your night be calm, your sleep deep, and your dreams as radiant as the cosmos. Good night, and until we meet again under the thoughtful night sky, fade out with soft cosmic ambience.